Your FastMCP server is running smoothly. But what happens when you need to combine authentication, rate limiting, performance tracking, and logging into a single, production-ready pipeline? Here, how to stack middleware in the correct order to handle errors first, enforce rate limits, measure execution time, and log everything, all while keeping your code clean and maintainable. You'll see the exact pattern for adding multiple middleware layers that work together seamlessly. From FastMCP, import FastMCP. From FastMCP server middleware timing, import timing middleware. From FastMCP server middleware logging, import logging middleware. From FastMCP server middleware rate limiting, import rate limiting middleware. From FastMCP server middleware error handling, import error handling middleware. MCP equals FastMCP, production server. Hash add middleware in logical order. MCP, add middleware error handling middleware. Hash handle errors first. MCP, add middleware, rate limiting middleware, max requests per second equals 50. MCP, add middleware timing middleware, hash time actual execution. MCP, add middleware logging middleware, hash log everything. At MCP, tool. Def my tool data, SDR. Return F processed, data. This demonstrates the middleware pipeline pattern for cross-cutting concerns in RPC systems. Middleware components wrap your core logic, forming a chain where each layer can inspect, modify, or short-circuit requests and responses. The distinctive aspect is the declarative composition order, where middleware executes in the sequence they're added, creating a clean separation between business logic and infrastructure concerns. The pattern works by intercepting calls at well-defined hooks in the request lifecycle. Each middleware receives the context and a call next function, allowing it to perform pre-processing, delegate to the next layer, then optionally modify the response. This creates a unidirectional flow where infrastructure concerns like logging, rate limiting, and error handling are handled orthogonally to your tool implementations, following the single responsibility principle. This approach solves the problem of scattered infrastructure code by centralizing cross-cutting logic in reusable components. You gain consistent behavior across all endpoints without modifying individual tools, while maintaining the ability to compose different middleware stacks for different environments. The trade-off is slightly increased complexity in debugging the middleware chain, but the benefits in maintainability and separation of concerns typically outweigh this cost for non-trivial applications. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tool servers. It transforms Python functions into structured tools that AI models can invoke, handling serialization, validation, and execution. From FastMCP server middleware timing, import timing middleware. This imports timing middleware, which measures and logs execution time for each request. Middleware pattern lets you wrap core logic with reusable processing layers, like performance monitoring. From FastMCP server middleware logging, import logging middleware. This imports logging middleware, the component that records all incoming requests and responses. It captures execution details for debugging and monitoring, ensuring you have visibility into every tool call. From FastMCP server middleware rate limiting, import rate limiting middleware. Imports rate limiting middleware, a request throttling component that enforces maximum request rates. This prevents API abuse and ensures fair resource allocation by capping incoming requests per second, critical for production stability. The middleware pattern allows clean composition of cross-cutting concerns like rate limiting. From FastMCP server middleware error handling, Import error handling middleware. This imports error handling middleware, the first line of defense against unhandled exceptions. It catches and formats errors before they reach other middleware, ensuring clean error responses instead of server crashes. Middleware order matters. This runs first to prevent cascading failures. MCP equals FastMCP, production server. This initializes the FastMCP server instance, the central orchestrator for all AI callable tools. The production server label identifies this instance in logs and metrics, enabling traceability across distributed systems. Hash add middleware in logical order. MCP, add middleware error handling middleware. Hash handle errors first. Error handling middleware is registered first to catch and process exceptions before they propagate through the stack. This ensures consistent error responses and prevents middleware further down the chain from receiving corrupted state. Always place error handlers at the top of your middleware pipeline. MCP, add middleware, rate limiting middleware, max requests per second equals 50. This applies rate-limiting middleware, capping requests at 50 per second, prevents server overload from burst traffic while maintaining predictable performance. The middleware pattern lets you compose these protections in a clean, reusable way. MCP, add middleware timing middleware, hash time actual execution. This adds timing middleware to measure execution time for each request. By placing it after error handling and rate limiting, it captures only valid, non-rejected operations, giving accurate performance metrics for successful requests. MCP, add middleware logging middleware, hash log everything. This adds logging middleware as the final middleware in the chain. It captures complete request response cycles, including timing metrics from previous middleware, creating comprehensive audit logs for debugging and monitoring. The placement after timing ensures logs include execution duration. At MCP, tool. Def my tool data, SDR. The at MCP tool decorator registers this function as an AI callable tool. FastMCP converts the type hints and docstring into a structured schema that AI models use to understand, validate, and invoke the tool. This is the core pattern for exposing Python logic to AI workflows. Function signature becomes the contract. Return F processed, data. This transforms the input string into a processed response. The F string formats the output with a consistent processed prefix, creating a predictable response structure that AI models can reliably parse and handle. Middleware orchestration pattern. The middleware chain in FastMCP2 transforms raw requests through sequential processing layers, where each component handles a specific concern while remaining unaware of the whole. Order matters more than you think. Error handling must come before rate limiting to prevent unhandled exceptions from bypassing your limits. A well-composed middleware stack makes your server both invisible to clients and omnipresent in control.
The middleware that does nothing still changes everything.